Morning, Assalamualaikum. Last class we stopped here. Okay. So last class is about airflow calculation and also the dew point temperature. Okay. So today we proceed with another example. In this problem, ethane C2H4, C2H6 burn with atmospheric air, and the volumetric analysis of the dry of the combustion yields the following: 10% CO2, 1% CO, 3% O2, and 86% N2. Okay, it asks you to develop the combustion equation and determine the percentage of excess air. Okay, first develop the combustion equation first. Now here it gives you the dry product. Okay, ethane, fuel, and air, and dry. So H2O is not measured in the dry. Okay, notice that you have CO in the product. Okay, so meaning that this is incomplete combustion. So less air. Okay, then, okay, we go step by step on the solution over here. Where here, the solution, it guides you to assume 100 kmols of dry product. Since the infos given are on the dry products. Okay, all of this dry. We assume 100 kmol of the dry product. All of this assume 100 kmols. Okay, so generate the combustion equation. The fuel, the air, and the dry products, and plus the H2O, which H2O is not measured initially, right? Okay, now the first question just now, it asks you to find the excess air. Excess air kan? Percentage of excess air. So percentage of excess air, we need to know theoretical air. Okay, we need to know initially what is the theoretical air. Remember the formula to find excess air? It's either using the equivalence ratio, kan? Ataupun dia guna this equation. Theoretical, using equation of theoretical air. Okay, this one is the actual. This one is stoic. A stoic. A actual, A stoic. A sini eh. Okay, I introduce the equation first. So to find excess air over here, we need the A actual over AS. Ataupun another equation yang involve equivalence ratio. Okay, but in the question just now, there's no infos given related to equivalence ratio. Okay. Now, we need to find A stoic, kita boleh cari from the stoic equation. This one, stoic equation. Okay, we can simply get the A stoic. Okay, I start from here first. To relate why we need to do this. Okay, so we get the A stoic 3.5. Okay, A stoic kita dah dapat 3.5. Now we need the A actual. Okay, again, stoic, which involve the theoretical. Sini, the products is only CO2, H2O, and N2. Stoic. Perfect combustion lah. Okay. Okay, now we want to find the A actual. A actual over here means the actual combustion. where the actual combustion involve all of these products as measured, okay, dry products plus the H2O, which is not measured. Okay, so kita assume 100 k moles sebab kita tak tahu the C of the mole of H2O produced. Kita nak cari A actual. Okay, A actual, we need all infos, including the H2O. Okay, boleh faham? Okay, sebab A actual kat sini. We need all infos so that we can get A actual. Okay, because A actual over here, dia involve the O2. Kalau kita exclude the H2O, kita takkan dapat the actual over here. Okay, now we need the mole of H2O produced. Okay, so first thing is to assume your dry products. Doesn't matter how many k moles, up to you. But usually the easiest is either 100 like this lah. Okay, 100 k moles of dry product. So ini saja 100 k moles of dry product. Okay, plus C of H2O, unknown of H2O. Now the mole over here, how we get? Yes, percentage. From percentage. So that's why bila assume 100 k moles, so 10% times 100. Dapat balik mole dia lah. Okay. Kalau you assume 10, then 10% multiply by 10. Okay. Now, the unknown over here, kita ada the set unknown. We do not know the amount of fuel. Okay, this is unknown amount of fuel used in order to produce the 100 k moles of dry product. Boleh? Okay. Okay, sebelum ni kita assume fuel. 100 gram basis kan? Fuel. Yes, ini kita assume product sebab itu the given infos. Okay. Now we want to find the unknown. Sekarang unknown dia is the fuel, mole of the air, and also mole of the H2O. Okay. Now buat balance. N2 balance. Okay, right and left hand side. Bila buat balance, you get the N2, this figure. Carbon 5.5 for A 5.5. Then bila buat balance on okay, nak try dulu buat balance so that you can see you can get the correct figure. Okay, try dulu. Boleh? Okay, example over here for the N, left and right side. 2 and 2 multiplied by 3.76 multiplied by the B equals to 2 multiplied by 86. So from there you get B equals to 22.87. Okay. Okay, now from there kita dah dapat the A, the B and the C. Okay, tadi kita assume all of these moles by assuming 100% K moles of dry product. Okay, in order to get the A actual, kita kena assume product is 1 K mole of fuel. Sorry, fuel is 1 K mole, not product. So apa yang kita dapat kat sini? Simplify so that you get the fuel as 1. Okay, do you know the reason why? Okay, sebab theoretical tadi yang kita cari AS tu is the fuel use is 1 K mole. So kita dapat A stock kan? So untuk nak dapat A actual, kita mesti samakan the fuel. Baru kita boleh compare. Okay, so the actual one pun kita jadikan 1 K mole. Then only we can compare the A value. So that's why the actual over here, then divide by 5.5. You dapat 1 K mole of fuel. Okay, so A actual kat sini is 4.16. This is A actual. Okay, kita tak ambil the 22 over here. Because the fuel is not 1 K mole. Kita tak boleh simply compare. Okay, so from there, masuk dalam equation, this equation, A actual over A stock. You will get this as theoretical air. So to get excess air, macam mana nak dapat excess air? Kita dah dapat theoretical. Sorry. Okay, sorry ini theoretical air, sorry. Theoretical air. Nak excess air. Okay, nak dapat excess air. Remember theoretical air adalah 100%. Kan? But this one 119. So to get the excess air is 100 minus 119 lah. In modulus, regardless of any sign. Okay, so here you get 19%. At stoic, theoretical is 100%. C yang mana? C mol H2O. Kena kira sebab kita nak compare dengan stoic. A stoic. Okay, where A stoic inclusive the H2O. Overall, the overall combustion equation. Bila kita nak compare, so we need to make sure semua sama lah. The rest of the thing sama. 1 kmol of fuel and the product pun ada H2O. Perhaps you can try kalau the stoic over here, stoic ni kan, you pun buat dalam dry. Dry product means you exclude the H2O, tapi dekat sini dia dah different lah. Dia akan jadi lain lah. Sebab you dry products kan. Then perhaps that one is another method. Okay, boleh ya? Okay, now tadi kita assume ini incomplete combustion sebab ada CO kan. But then when calculated, kita dapat excess air. Okay, so meaning that this one is excess sebab ada O2. Dia excess air, tapi perhaps here is only 1%. So that means the fuel is not completely consumed. Kalau tak ada O2, then kita boleh assume totally incomplete combustion, less air. Ini dia lebih. Boleh. Okay, can proceed. Can you need take some time? Proceed. Now, tadi excess air. We proceed for air fuel ratio. Once kita dah dapat A actual, now we find the air fuel ratio. Now, air fuel ratio here is for actual. Dekat question dia tak tulis actual atau stock kan. So, assume actual. Now, A actual multiplied 4.76 and the molecular weight of the air divided by molecular weight of the fuel. Sorry. Okay, this one the fuel is gas. So kita akan guna dia punya atomic number. Sorry, molecular weight. Okay. Okay, for air fuel. Now we proceed for dew point. Okay, dew point we had previously try on the previous exercise where kita boleh samakan the partial pressure and the mole of the products. Okay. Dew point kita perlukan the P of the H2O to find the T of the H2O. Okay, this one required to find. This one is to find. Okay, macam mana nak dapat PH2O? By using this equation. Kita samakan dengan mole fraction of the H2O. Okay, first thing, identify first what equation to be used, which equation to be used. So now we identify this. So you need the infos of NH2O and total. And here is the mole fraction. Sorry, the mole. Okay, mole. N mole. So NH2O tadi kita dapat 3. Okay, how we get 3 from the bukan the actual. Ini actual yang dah simplified. where the fuel is 1 kmol. This one from this equation. From this equation. Okay, so kita dapat 3 over here. Okay, means yang simplified for 1 kmol fuel ni, this is the finalized equation that you should use. So 3 mole of H2O and total, you need to consider all of those moles. Okay, so kat sini nampak all of those moles. Inclusive the CO tadi, 0.18. Okay. Okay, so P tadi, dia ada bagi tak nanti? P atmospheric air. So at STP. You know not this short form, STP. Yes, 25 degrees C, 1 atm. 1 atm equivalent to 101. Okay. Okay, so ini just take the value from the statement, then you akan dapat partial pressure of H2O. Okay, then cari infos in from table A5. Nanti saya buka table A5. I have uploaded the table in CN. Kan? Okay. Apa tadi temperature? Sorry, pressure 14. Okay, 14 between these two. How do you want to do? Interpolation. Okay, but interpolation between 10 and 15. Then you will get the value. Okay, 10, 14, 15. Okay, so you interpolate. Fifty-two point three four. Okay, we do one more exercise. A natural gas. Okay, natural gas fire industrial boiler operates with an oxygen concentration of 3 mole percent in the flue gas. Oxygen concentration in the flue gas. So basically dia macam ni. Natural gas CH4 plus O2 and N2. Oxygen concentration 3 mole percent in the flue gas. So dekat sini basically kita ada O2, H2O, and 2. So this O2 is 3% in the flue gas. Determine the operating air-fuel ratio and the equivalence ratio. AF. Okay, actual lah. Macam mana kita tahu actual? Mention the operating. And the equivalence ratio. Okay, treat the natural gas as methane. Methane is CH4. Okay, so first thing first, we need to find the combustion equation. Okay, kat sini dia dah bagi the tips. Use the given O2 to find the air-fuel ratio by writing an overall combustion equation, assuming complete combustion. Okay, no dissociation. That means all fuel C is converted to CO2, H is converted to H2O. No CO lah. Okay. Okay. Here, generate the combustion equation. The fuel. Okay, so we need to find the A. The products just now, CO2, H2O, O2, and N2. Okay, B tadi. This one is mole percent. Okay, so now the unknown is A and B. Okay, so kita cari what is the A and B. Dua unknown, so we need to have two equations. Okay, so from the mole fraction, okay, the 3% tadi adalah mole percent. 3 mole percent in the flue gas. This is the one that equivalents to 3%. So N and 2 over N mix, N total. This one is N total. B, okay, over the total. Total here. Okay, yang ini tadi, tahu tak macam mana dapat? Yang X, kan? Ini Y over 2. Y over 2, okay? Kan? Okay. So ini kita cari mole fraction of the O. We have two unknowns, B and A. So kita dapat another equation. Equation 2, this one equation 1. Okay, then substituting both equation, you're gonna dapat the A 2.368. Boleh? Can relate lah. So this is the A actual. Mana tahu A actual? Macam mana kita nak categorize A ni A stoic ke A actual? Sebab okay, A ni adalah dari sini kan. Ini adalah the actual combustion equation. How we know actual? Sebab dia ada O2. Okay, so ini adalah actual equation. Okay. Question tadi ask you to find AF actual. Okay, so we proceed to the next slide. FU ratio, kita tahu FU ratio is for actual. This is the equation, FU ratio. So A ni yang tadi kita guna adalah A actual. A actual. But sometimes you will get confused. A actual, A stoic. How to differentiate stoic and actual. Kalau stoic, we simply take the fuel, the stoic combustion equation. Product dia, this one. 3.76 A and 2. Okay, this is stoic. Stoic ataupun the terms are theoretical. Okay, so how to get this A stoic? Ingat lagi? From the formula. Yes, 514. Ini kalau stoic kita boleh terus cari guna equation. Kalau actual tak boleh. Okay, ini A stoic. So, okay nanti kita proceed for A stoic. Now for AF actual, guna A actual yang dapat tadi equivalent to 20.3. Actual. Molecular weight of the methane. 16 lah. 16. Sebab sometimes dia bagi biasa saya akan bagi molecular weight. Macam C usually 12, H is 1. Dia kalau more accurate, ini C 12 point something, H 1 point something. That's why you boleh dapat point-point ni. Yang molecular weight of the air ni pun dia bagi accurate value lah in 2 decimal point. Biasanya kita just guna 29. Okay. Okay, next is to find the equivalence ratio. Equivalence ratio, kita tahu the equation AF stoic over AF actual. Okay. AF stoic, cari AF stoic using the A stoic. Stoic tadi. So that's why yang stoic tadi from the chemical formula of the fuel, so you akan dapat 2. Kan, ni A stoic. A stoic ni akan guna to find AF stoic. Sebab from equivalence ratio, they involve the stoic. AF stoic over AF actual. Okay. Apart from this, actually, the equivalence ratio, selain guna full value of AF, you boleh guna juga A only. Using the A only. Okay, why I say that? AF, here. Okay, we know that AF is 4.76 A stoic. This one kan, air, then over fuel. Over for actual, same. The difference is only the A. Yang lain semua sama. So, kita boleh cut off. Fuel 4.76, 4.76. So at the end, you just boleh guna the A value only. Dapat sama kan? Okay, so kat sini equivalence ratio less than 1. Excess. Betul tak? Excess air. That's why kita ada O2 dekat dalam produk. Less than 1, excess. Apa term ni? Lean sorry, fuel rich. Sorry, no, fuel lean. Fuel lean. Fuel lean or excess air. Okay. Now, tadi semua example in the fuel is in gas form. Now, kita try for solid fuel. Okay, solid fuel where this is the solid part. Plus H2O here if the fuel is in wet. Ada some moisture. Okay, so basically dia sama je. The fuel, air, and then plus the products. CO2, H2O, O2, and 2. O2 if excess air. Okay. Nah, ini solid tu. Okay, here they mention to consider the presence of water content in solid fuel. Now, this one, dia kata to neglect the N in the fuel, just to simplify the equation lah. So that's why kat sini dia remove the N. Tapi practically you need to include whatever component in your fuel. This one from the given example previously, the proximate and ultimate analysis of Bagas. So from there we find the chemical formula. Ingat lagi? Ultimate analysis tu. Okay, so remember to normalize the moles to C. Okay, with respect to the C. So you akan dapat in the end, this is the chemical formula of the fuel. Okay. Okay, ini okay. So let's say this one, it includes the H2O with the fuel. Wet fuel lah. Okay, this is not compulsory. It depends on your type of fuel. Okay. Okay, for the statement over here, Bagas fired boiler operated with equivalence ratio of this. Report the composition of O2 and CO2 in wet and dry basis. Okay, ini dia nak product. From the product over here, report it in dry and wet basis. Okay. Now, from tadi kita dah dapat the chemical formula, then we generate the combustion equation, inclusive the O2. Yeah. Now, we have unknown of A, B. Info yang dia bagi tadi is just equivalence ratio. So from equivalence ratio, apa yang you boleh cari? We know AF start over AF actual kan? Equivalence to A start over A actual. Betul. So A start kita boleh dapat daripada start equation. Kan? A actual from here. Kalau A start, kita guna just the equation just for the mana tadi? From the chemical formula here. So ini is our fuel. So start using the fuel A start build up at start. Okay, sini satu kan, H2O. Your, this one lah, 0.395 over over 2, yes. Y over 2. Okay. Now this one 3.76A. Okay, sekarang kita ada CHO. Need to find your A stoic from the equation X plus Y over 4. Kita ada O. Yes, correct. Huh? A? 1? 1.05. So, okay then, daripada equivalence ratio punya equation, you boleh dapat A actual. Okay, try calculate apa dia punya A actual. Huh? Tak boleh pakai tak. A actual, okay. Daripada equivalence ratio punya equation, kita boleh dapat A actual. Equivalence ratio, dia dah bagi 0.387. So this one means A stoic over equivalence ratio. Betul, dapat. Okay. Combustion. Okay, now dia nak, okay, sekarang kita dah dapat A actual. A actual is 2.601. So, kita boleh cari the unknown B over here. Cuba try buat balance, then you will get the B. 1.6. Okay, so masukkan 1.6 kat sini. Then the question tadi dia nak composition of O2 and CO2 in wet and dry. Okay, what you should do next? Sorry, composition. Okay, composition. Equation of composition. Product composition. Apa equation dia? The mole fraction tu. Composition means the mole fraction. Mole fraction of O2
kalau macam ni buat entrance boleh pakai sendiri macam maksudnya kita boleh dapatkan sebuah entrance composition from question yang
balance. Bukan. Kalau composition means mole fraction. Mole fraction kita dah kena dapatkan total mole of the product. Okay, mole fraction in equation dia yang ni. General equation, mole fraction N of the component lah. In this case O2 and CO2. And this mole. N total kat sini, it depends wet or dry. So kalau N total, boleh faham? N total wet, semua termasuk H2O. So
by operating from the point position
boleh. Dia guna equation ni je. Water. Okay, so the difference is the NT. NT wet and NT dry. Dapat tak? Same. Okay, so then cari O2 and CO2 in wet and dry basis. So you categorize your composition in wet and dry. Untuk CO2 0.08 apa? Betul. Wet 0.08 betul. 0.08 betul. Kalau 4 decimal point 0.794 kan? 0.0794.
Sebabnya of saya macam ni kan info can be given for this month dalam application is in terms of 1.6.
Okay, boleh. As long as dia 0.08 lah. Dia tak banyak beza, then should be okay. Dapat all the figures. Okay, so basically inilah jawapan dia. This is the answer for wet and dry. This is how you answer the question. Sebab dia just tanya report the composition in wet and dry. Okay. Clear? Confused dekat equation tu lah. Nak gunakan actual, stoic and actual. Stoic ada equation, stoic. Kalau actual, dia depends pada balance. Dah kena practice banyak kali lah. Okay. Nah, this ada exercise. Dekat dalam slide you ada tak exercise? Exercise yang sama. Okay, yang dalam slide you dekat ni dia tulis stoic equation kan? Just amend it to be the combustion equation. Okay. Okay, yang ni you try buat at home. Try submit by Wednesday. Boleh. Next Thursday pun kita cuti kan? Ha? Next Thursday hari wilayah. So Thursday cuti juga. On Wednesday lah you submit. Because I want to know Wednesday. Khamis cuti kan? Jumaat juga. Sebabnya, sekejap ini settlekan by Wednesday, you submit. Answer, you try to do and try to answer. This one, I rasa yang ni soalan midterm kot. Or final exam previous semester. Okay, so by this we finish chapter 2 already. Kita dah habis chapter 2. So next week, Friday, I akan masuk chapter 3. Bila chapter 3 ni dia will be more complicated. Dia ada involve temu sikit. Temu tu tak banyak, just how to read the table lah. Okay, so any question for chapter 2? Try kena try buat exercise balik.